So now data science is clear, right? Now we will enter into artificial intelligence.
Yeah.
So we have already discussed what's the purpose of artificial intelligence. That is, think like human, act like human. Basically, we don't always think rationally. Not always, every time. We don't think, means we don't do things rationally. So because of lot of things, the way we were grown up, where we are grown up, and depends upon surroundings, all these things we behave. So that is the reason we don't think rationally, never. So that is the reason they want to make a machine that thinks like and acts like human. So that is an artificial intelligence uh, discipline. So we have two types of AI. One is weak AI and other one is strong AI. So it is artificial narrow intelligence. Whatever till now we have, these are all artificial narrow intelligence only, because we are not able to completely mimic or make a mission that can mimic a human. So Apple, Siri, Amazon's Alexa, IBM Watson, and autonomous vehicles, that autonomous cars, automatic cars, all those vehicles are weak AI only, because they cannot replicate human at any cost. So now, till now, we are in weak AI stage only, or artificial narrow intelligence stage only. Now they are doing a lot of research, means to make a artificial general intelligence or super intelligence. You need to find out a new algorithms. That is what a research, artificial intelligence a research engineer, artificial intelligence researcher, these people do. If you get this kind of role, you will invent a new algorithm that can actually make a artificial general intelligence, means that can actually make a machine exactly think and behave similar to human. So but we haven't reached that stage. So as of now, what we have, all applications, everything comes under weak AI only. Obviously, deep learning and machine learning are subfields of artificial intelligence, whereas deep learning is actually subfield of machine learning. Now again, I'm just trying to connect it with the cloud computing, because so that you will never have a problem with cloud computing, or else, because what if you do the artificial intelligence related algorithm, that is nothing but machine learning and all, then it is called legacy computing. Whereas if you do it in a cloud, it's called cloud computing. But what cloud offers for artificial intelligence, what is the cycle? For example, to collect the data, so they made it this process also simplifying, because if you remember, we have seen the resources in IBM cloud or some other cloud. Yes.
Yeah.
So by using those resources, by connecting each, we can actually work on same project in cloud. So that's what I want to tell you here. It is not much required for us. So but as of now, actually that is how artificial intelligence related algorithms can be connected with the cloud computing. Now few examples of artificial intelligence applications are speech recognition, customer service, computer vision, recommendation engines, and basically fraud detection. This is very much useful in banking and all. So now we have seen the theoretical concept of artificial intelligence and what are the types of artificial intelligence. Now basically we are entering into the actual crux of the session, that is machine learning. So if you go to the machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that humans learn and gradually improving its accuracy. If you see definitions of machine learning, deep learning, all would be same only, because by and large, all does the same work, but at what capacity they do is what defines the type of algorithm. If machine learning, that capacity is very low, only 10% of human behavior or human thinking will be captured using machine learning algorithms, whereas deep learning, it would be 40 to 50%. If it is artificial super intelligence, then it is 100%. Till that stage, still we haven't reached that stage. So now, basically, in machine learning, main purpose of machine learning algorithms are two. One is classification, second one is prediction. These are the two. So, and deep learning is a neural network, is sub part of machine learning, that anyway we have discussed before. So now what we'll see is how machine learning works. So first thing is a decision process. You write a machine learning algorithm either for two purposes. One is either to predict something is going to happen, rain is going to fall, or this bank customer is going to default, or this patient is going to get cancer, or this car is going to met with an accident. This is prediction. Or classification, classifying your customers based on set of rules, classifying your patients based on their symptoms. So these are the two types of, basically these are the two types of output we get from these machine learning algorithms, either supervised or unsupervised. So that's the decision process. And then the most important thing is accuracy. This is the second step. We use some error function to decide the accuracy. See, just focus on this machine learning working procedure, because they might ask questions on this. The first one is writing a algorithm, that is fine. But the second step is your accuracy. You have to assess the accuracy, how close you are. See, there are plenty of algorithms, but all won't fit to the same problem. Some problems are very well fitted with some algorithms. So that is the reason you have to check the accuracy, so that you can actually provide a proper solution for your customer. That's the second step. And the third step is optimization. After checking the accuracy, again, you evaluate the whole process and optimize that, so that you are getting a good accuracy and a consistent result for the customer. So this is how a machine learning algorithm works. So you write an algorithm. Once you write, after you write an algorithm, you have to check the accuracy. And once you check the accuracy, and you just re-evaluate, and you do some modifications, or find out a new algorithm and optimize the accuracy, so that the client or the customer can get a consistent and accurate results. Clear? Three stages. Hello?
Yeah.
So that's how a machine learning works. Now and then, so now what are the types of machine learning? This is very important now. You have to focus a lot now. Supervised, first one is supervised, and then unsupervised, and then a reinforcement. Okay. So what is supervised? We'll see later. But now try to remember these algorithms. What all are algorithms that comes under supervised? Just completely focus on this, because these algorithm names will be helpful for tomorrow, day after tomorrow's interview. Okay, so very much. We have in supervised machine learning, we have 4 types of algorithms. One is regression. This is for the prediction. Second one is a decision tree and a random forest. And last one is absolutely classification. These are all classification algorithm models. So now in machine learning, we will have 2 types of, we expect 2 types of output. First one is prediction. Prediction means you are predicting something to what's going to happen tomorrow using this previous data or historical data. It could be anything. Rain may fall or people may die, whatever it may be. It may be. So either prediction or classification. So in supervised ML, we have prediction algorithms, already written algorithms, and then we also have a classification algorithms. In regression, we will have a linear and a polynomial and a decision tree and a random forest. Whereas classification is nothing but you classify your bank clients, you classify your patients, you classify your school students, you classify houses in your village, you classify players, you classify, you can objects, or you classify FMCG goods that are inside the shop. So using some specific variables, some specific attributes. Now for classification, what kind of algorithms we have? First one is KNN. It's called K nearest neighbor. Second one is TNS. Third one is logistic regression. Logistic regression is making yes or no, these kind of, yeah. And Navy base and SVM, support vector machine. This is given in that JD. So first, these are the supervised machine learning. In supervised machine learning, you have 2 types of outcome. One is prediction and other one is classification. So these are the algorithms. Clear?
Yeah.
And we have unsupervised machine learning, the next one. Now in unsupervised machine learning, you only tell me what could be the outcome you are expecting. Yes?
Yeah. So like the outcome means they will like it's we are inputting unlabeled data. So
Yes?
yeah, we are inputting unlabeled data. The data won't be labeled. So the machine
Yes.
has to identify the
What's the outcome? See, in supervised ML, the outcome is very simple. You put the labeled data and then you expect to either predict something or classify based on your label only. Whatever you are given, based on that label only, you want to classify those persons. For example, in your, if you have a school, in that school, 10th class, 5th class, 4th class, 6th class, 7th class, like that you have given an example data set and it was trained on based on that. So once you give new data, again, it will take out the pupil from the 5th class. If you give new data, they will classify based on 10th, 5th, 6th, 4th. That is called supervised ML. In unsupervised ML, what you said is right. Unlabeled data you give, that means you are not labeling before, like you did with supervised ML, 10th class, 4th class, 5th class. Here you are not labeling. So here also the same thing happens. Here it convert it into clusters. Because you are not labeling it now, you cannot call it as a class because it is not classified before. Now these are all clusters based on some specific similarities. Based on some specific similarity. For example, 0 to 10 years girls, one cluster. 10 to 20 years, one cluster. 20 to 30 years, one cluster. Basic on some other attributes, they will do it. So that is the clustering. And similarly, association analysis. Association analysis is nothing but similar to that only. How they are associated with the other. So in unsupervised ML, we have again clustering and association analysis. Here algorithms are SVD, singular value decomposition. This is used to cluster the unlabeled data. Fantastic. And then we have hidden Markov model. And then finally for association analysis, we have a priori and then FPG. This is called frequent pattern growth. So this is clustering, hidden Markov model, and association analysis. This is what unsupervised ML. Now what left is reinforcement ML. So in reinforcement ML, we have around 3: Q learning and state action, reward state action, and then deep Q neural network. These are the 3 algorithms we have. So can you tell me what is reinforcement ML? So, hello.
Yeah,
Yeah.
Your voice was breaking.
Okay. So now just to look back into supervised ML and unsupervised ML and reinforcement ML, it's very simple. For supervised ML, what you said is absolutely right. You give a labeled data set and you train the algorithm and you ask your computer to either classify or predict the data that is going to come later. So this is what outcome you expect in supervised ML. Similarly, in unsupervised ML, you basically you don't give a predefined what we call labeled data. So that is the reason here it either clusters, either it converts into clusters or it create associations, either this or that. Because as you are not giving the labeled data, the system has to decide on what parameters it is going to make it into clusters. That's why it's called unsupervised, because human is not supervising that algorithm. And then the third one is reinforcement ML. In reinforcement ML, it is again similar to unsupervised ML, but one step ahead. So here what happens, once it is done, once one association is created, means you have to after giving the new data, it will convert the data into clusters or association. After that, it will use it as a feedback. And then it will try to improve the accuracy using trial and error method. That's why it's called reinforcement machine learning. Means whatever is there.
Your voice is breaking.
Oh, okay. So now?
No.
So supervised ML is clear?
Yeah.
Unsupervised ML is clear?
Yeah.
Reinforcement ML is also clear, or should I explain one more time?
No, that is fine. Like I have a overall idea of these 3 things, but
overall idea you have, and also
the details.
you know these. Remember these algorithm names also, because that's what, if they take interview on basic level, this is what they expect. If it is deep level, then they will go into actual algorithm, how it works, and some statistic terminology. But basically what I expect, whatever you said, based on that, they will look into you, whether you have a clarity on artificial intelligence or not, whether you know what kind of algorithms they use or not. These kind of things they may ask. So now this supervised, unsupervised, and the reinforcement is clear. Now what kind of library, because we use Python, so what kind of library we use to execute these algorithms? Keras, and then TensorFlow, NumPy, and these are for the support, because you need to create a you need to work with numbers. So these NumPy, Pandas, SciPy, these are support libraries, whereas Keras, TensorFlow, Scikit-learn, Matplot is also a support one, PyTorch, Tino. So these are basically actual libraries. Using this, you will work on machine learning models. Clear now?
Yeah. Yeah.
Okay, just a minute. So now we have looked into machine learning. So now we will increase our capacity, increase the capacity of a machine a little higher. So now whatever we have seen, that is a 10 to 15% of capacity that can copy the machine. Now copy the human. So now we want to increase that capacity a little more. So now that is the reason we invented a neural network. So neural network, one step ahead, it will try to reflect the behavior of the human brain by recognizing the pattern and solve common problems. So now how it works? You see the diagram. See, this would be very important. Can you explain?
Yeah, there will be an
Yeah.
input layer
Yes.
and some intermittent layers.
Yes.
So more hidden layers, and then finally the output layer. So the data passes through all these nodes.
Yes.
Nodes, and finally, like when the needed precision is obtained, it will be output.
Yes. So that's what our here, whatever diagram I was showing, that is deep neural network or deep learning diagram, because you have more than 3 layers. Total, how many layers we have here? 5 layers. So it is a deep neural network. Yes, yes. So whatever you said is by and large right. So here data passes to each layer, and if you see in each a circle is called as a node, that is equivalent to neuron in our human system.
Brain neural system.
Yeah, so a node is equals to a neuron. So now, for example, if you take one example here, you give an input data, okay, and each layer and each neuron will have some kind of weightage that is decided by your algorithm, what kind of you are given. So now, as it is passing through that node, when it crosses that threshold, because there are plenty of nodes now. See here, you have five nodes. For in this layer, it will, for example, okay, is it audible?
Yeah.
So for example, if from the first node the data is coming, in that case, what happens? It will check with all other nodes in the second layer. Once it crosses the threshold of any node in that layer, then only it will allow to enter or seep into the next layer. So like that, it crosses the each layer and finally creates an output once its accuracy, or once it reaches the expected accuracy. So for example, if you take a simple linear regression kind of neural network, see, this is how it will be. See, each neuron will have a weightage, and x1 is a variable. Yes. Hello. Hello.
Like, are you speaking or?
Yeah, is it audible?
Yeah, yeah, now only actually for like last few minutes it was not audible.
Okay, that's why. Okay, fine. So neural network, for example, if you take linear regression model, So this is the typical example. See, because you have plenty of nodes in it, W1, X1 is one node, and W2, X2 is another node, W3, X3 is another node. So like that, you will have a plenty of nodes. This is example for the linear regression model. Now, once this X1 is nothing but a data input, whatever data you are inputting. Okay. So now once it crosses that threshold, then you will get the output as a function. So this is a simplistic way to explain, but when you actually work on neural network, then you will get a more clarity. When you do hands-on neural network, then you will get a clear picture. But as of now, what you require to know is layers and how data passes through that layer, and finally how you get an accurate result. That is clear, right? Hello. Hello. Yeah, okay. So now this is, and then, so what are the types of neural networks we have? One is basic neural network, and second one is deep neural network. Deep neural network is also known as a deep learning. So basic neural network is, here we have 5 layers. If you have a 2 or 3 layers, it is called basic neural network. If you have more than 3 layers, it is called deep neural network, because depth of layers is increasing. Clear?
Yeah.
So those are the 2 types of neural network. Now here, using neural networks in IBM Cloud. So basically, to look, if you open IBM Cloud or any cloud, you will have IBM Watson or Cloud, these kind of tools. With that, you can actually create easily, means easily you can create, because you don't need to write algorithm, because IBM Watson, they have already written an algorithm you can use for whatever application you want. So that's the benefit of using cloud applications. So now we have covered machine learning, under which neural network, which has a more capability to to mimic human, under which basic neural network also we have covered, and under which now we will see deep learning or deep neural network. So deep learning will take same kind of definition, whereas depth of layers, okay, whereas depth of layers will increase. We have 10 minutes, after that we'll join. So depth of layer increases. So now basically, what is the difference between a deep learning and then a machine learning? So the simplest difference is, in machine learning, once you get the data, it may be raw, or if you, once you get the raw data, then what you will do is, you process the data, you clean the data, and then you format the data, you label it, you label the data properly. Once you labeled it properly, then you will classify. After that only you will use it for your machine learning. Whereas in deep learning, data is not going to be pre-processed. For example, images or videos, will you pre-process it? Or text, will you do pre-processing? Nothing. You just give the raw data like that. Still it is able to process your data. That is the power of deep learning. Got it? Hello?
Yeah, I can hear.
Yes, we have 8 more minutes. We'll actually, after,
Yeah,
once we complete, we'll join. So how deep learning works? Same, using neural networks. That's multiple layers connected with nodes. So now we will see what all types in deep learning. One is convolutional neural network, and second one is recurrent neural network. Convolutional neural network, the best example we can take is computer vision, CV. Computer vision is